Welcome to Module 4. This is our first lesson on Module 4. So before I go into this lesson, I just want to say there was a video I sent which asked you 3 different questions. They really wanted to understand your understanding of what the whole principle of protection is really about. So what I did in your actual module notes I sent you last week is I put in all the different answers that people who responded to the questions have provided for us. And I am not going to include that in the lesson that I'm doing for Module 4. However, I'm hoping as we continue on Module 4, you can really see some of those answers coming out or those questions being answered. So in this module, we're really wanting to look at what is unit protection and what are the zones of protection. So coming from our graded overcurrent systems, it is easily picked up that if we are not talking about a simple or a plain radial system and we start bringing in the rings or we start bringing in a lot of interconnected system with 2 different points of supplies, it becomes more difficult to do the graded system for that protection scenario. So because of this, it was then decided that we need to have different types of systems as well that we can utilize to look at your protection that has got a lot of networks involved in it. So one of the things that was then introduced was what we call the unit protection. And what this does really is looking at a system and segregating it into different or smaller systems or components so that the protection can be done per component or per section of that system. And the benefit that we get from this unit protection is that you can apply it then throughout your protection system. And because there is no grading involved in it, your protection should act relatively fast in isolation of your section that has got a fault in it. One of the unit protections that we know of or are very aware of is what is sometimes referred to as differential protection. And that really looks at your incoming versus your outgoing in any system or circuit. And all that you're wanting to do is that you want to have the same current that was in would be the same that you're wanting to have out of that system. So that's what your differential protection really looks at. So in our unit protection scheme, we usually define the scheme as an inexpensive scheme. It's fast and it is quite stable as it only looks at small portion of your entire system. And so therefore we really utilize it for all different types of equipment that we have on our systems. We can use it for transformers, we can use it just to look at your bus bars, we can use it to look at just your reactors or your capacitors. We can utilize it just to look at your lines if you're going from one substation to the other substation, or even if you have what we call our generators in our power stations. And this unit protection provides a comparison of your quantities from your boundaries and your protected zone. Now, when we talk about a protected zone, what do we mean? A protected zone really is a part of a power system which has got a certain protection scheme that we're employing into that zone. And it's established around each power system equipment. And when a fault occurs on any of the protection zones, then only the circuit breakers within that particular zone will be opened, and all of your other zones will remain connected onto your system. So once we talk about a zone, it might be 1 or 2 units put together that are closely linked to one another. And we talk of them as a zone so that If you had a protection within that unit that did not trip out, then your zone can be able to look at whatever has happened wrong within the system and take that entire zone out while the rest of your network remains in place. So the picture you have here is what we call a simple unit protection scheme, or a differential scheme, as you can also name it, of a line. And you have really a transmission line where at the end of each part of this line, we've got CTs that are measuring whatever is happening in there, and those get connected directly to relays. So if you happen to have a fault that is outside these CTs, in other words, they fall outside what you see as the boundary where it's saying protection zone, as in that point number A on your left hand side, on your right hand side, sorry, where you have that F1, you can see that it's external to where your CTs are at. So if a fault occurs there, then your fault will not be isolated by this protection zone because it's not seeing that fault. That fault must be picked up by another protection zone. But if your fault, look at the bottom now where F1 is right in the middle of your protection zone, then if that is the case, that fault will definitely be isolated by your circuit breakers that you have into this protection zone. Then if you're looking at this picture, we now have a variety of different types of schemes or different types of systems that are involved here. Let's start with the picture on our left hand side. In the picture on our left hand side, you can see that number one, we've got two generators that are going into circuit breakers. Then we've got a station bus bar, circuit breakers. Then you have a transformer, another set of circuit breakers. Then you have another bus bar, circuit breakers. You have a line, and then you've got other circuit breakers and a bus bar and another set of circuit breakers. So what you really have here is that you've got a generation that is going through to your transmission network, and then it will go through up until where you have your last transmission substation. Hopefully at that point it will be going out to where your distribution is going to be. Now, when we talk about now zones of protection, we're talking about this type of a system. Number one, in this type of a system, you've just have got too many networks that are involved. Okay, so it would have been easier for you to do what we learned in your graded overcurrent systems if it was just one generator system. One generator, then you would have had a radial system in there. But because it's two generators, you've got an interconnection between the one side to the other side in case one of your generators becomes out. So that is why it becomes a little bit difficult for you to do your overgraded system over here. So we need to do our unit systems in it. So the way that they have shown it is, if you look at the generator, each generator is linked with a circuit breaker, and they say that is a zone of protection. So that generator is getting looked at by that one circuit breaker. And if the generator had to have a fault in it, then we expect that one circuit breaker to be able to act on that fault. Okay. Then you look at the second part now, going down from the generator, you can see where it's saying it's a station bus bar. And in the station bus bar, you can see that you've got the circuit breakers on both sides of that bus bar. So the one set of circuit breakers are the ones that were looking after the generator. Then the other set are the ones that are looking below or are below our station bus bar. So these four circuit breakers can be utilized to isolate a fault that is happening within your station bus bar. And we call that another zone of protection, where now we are looking at your station bus bar. And what does it really mean is that if you had to have a fault in that bus bar, then all of these four circuit breakers, we would expect them to act or to trip on that fault. And if all four of them trip on that fault, what does it mean for your generators? By default, for this type of a system, it means that your generator will also be out of supply and there will be no supply onto the entire system will be lost. Then if we move away now from the zone where we had the station bus bars and we come lower down, what do we have next as an equipment? We've got our step up transformer. Okay, so you've got step up transformers on both sides of that system. And what is surrounding the step up transformers? You can see that on either side, top and bottom of the transformers, you've got circuit breakers that are looking out for that transformers. And this system keeps on sharing the circuit breakers because the same circuit breakers that are on top were the ones that were at the bottom looking after the station bus bars. They also look at the transformers and protect those transformers. So again, if you had to have a fault on one of the transformers, then both its circuit breakers would open and that fault would therefore be isolated from the system. And the nice thing about this system is that if only one of those transformers is isolated, then the other transformer can be utilized to feed into the rest of your system. In other words, the bus coupler at the bottom of where these transformers are at will be closed so that we can be sure that your left hand side or your right hand side, depending on which transformer is faulted out, can be able to have supply continuity going out onto them. Then if we move away from the two transformers and we look now at our bus coupler, and you can say it's a bus coupler scheme if you want to say it like that. And in our bus coupler, you can see that our bus coupler is involved in two different schemes. Okay, you've got the two circuit breakers on our left hand side, and then you've got that breaker that is the actual bus coupler. So that is the one side that's looking after this bus coupler of ours. So if anything had to happen within that bus coupler, this portion could take it out, or if something were to happen on the bus bar before you get to your bus coupler. Then on your other side, the right hand side as well, you've got two circuit breakers that are also ringing into this bus coupler. So you have a similar scenario there. If anything had to happen on that portion of your bus bar, then that portion can be taken out. And the nice thing again is that you can always have one side of your bus bar connected into this scenario. Then as you go down again, you now have a line. Okay, so before you had a transformer between two circuit breakers, now you just have two circuit breakers. So that means that in between these circuit breakers, as the arrow is saying, you've got now a transmission line in there. So that looks after your transmission line. Is like the slide that we just had before, where you had two sets of CTs onto a transmission line that you have in there. So if anything happens within those transmission lines, then those two circuit breakers would be able to open and take out that fault. And so it goes when you go to the bottom part where you have again that one bus bar that is in there. So this is talking about overlapping zones of protection, and you can see why they call them overlapping, because we utilize the same circuit breakers at least two or sometimes even three times in order to protect our entire system into it. Then I want you to look at the system that is on the right hand side. So in the right hand side system, you now have got four generators and they name them A, B, C, and D. And then these generators are going out and you've got two transformers that they are feeding into, and then they go out onto your substation HV bus bar, and then they go out to another two transformers, and then they go onto your MV. So you can look at this scenario on the right hand side as a generation, transmission, and distribution network in one. All right. So again, when we look at how do we do the zones of protection, you can see firstly that each generator must be protected individually. All right. So your G and your A means that A is actually a circuit breaker, that B and that C and that D are circuit breakers. So each generator have got a circuit breaker that looks at it. Then you've got your generator bus zone. All right. And in the generator bus zone, you can see that your A, B, C, and D circuit breakers will be there to protect that bus zone. as well as the circuit breakers on the other side, which are for your transformers, your E and your H, can be utilized for that generator bus zone. So if you had to have a fault on this bus zone, all of those 6 circuit breakers must open up so that the fault can be isolated from your system. Then you've got on either side the transformer zones. So the transformer zones are looked after by E and F, and then the other transformer zone by H and I. So again, if something had to happen on either one of those transformers, if it was the EF transformer, then those 2 circuit breakers would open up and that fault would be isolated. If it's the HI, then it would be those 2 circuit breakers that open up to isolate that fault in there. Again, the nice thing about this system is if only one of the transformers was to be faulted, then the other transformers will still be able to continue with the supply so that you can still get to the substation HV bus zone. And that substation HV bus zone now is where you now gonna have again your G and J as well as your K and L circuit breakers looking after it. Okay, then between your transformer zones and your substation HV bus zone that I just mentioned, you also have your transmission line in there, and you can see that you've got at the end of each transmission line that there are 2 circuit breakers that are protecting it again. And so it goes. Once you've reached your substation HV bus zone, you go again into these distribution transformers now, where again you've got your circuit breaker at either side of those. Okay, then your P that you are seeing there is the same thing or a similar thing as your bus coupler that you had seen before on our left hand side, but now we just usually call it, because it's on the MV side, we usually call it as a bus section, which really is all that it does is to put the 2 buses together. So in case the one bus bar cannot fit where you've got your Q, R, and S, then you would be able to take that transformer and feed it into the TU and V bus bar with the second transformer that was in there. So now to sum it up on everything that we had seen, we have put in a system here where you've got 3 generators. You've got one that's sitting at a zone 1, one sitting at zone 2, and another one sitting at zone 10. So those are 3 generators, each one going into a transformer, and then there are bus bars going into lines. All right. So then they ask a scenario, or they put scenarios in where you've got these 2 crosses. If you look closely, one is at P1, the other one is at P2. So if you had to have a fault at where P1 is at, then it means that P1, because it's on zone 5, then the breakers of zone 5 would open to isolate that fault. And one of the breakers of zone 5 is the B42 and the B24. But if you had to have a fault at P2, then at P2 you are sitting at a different zone because it's zone 4, and you expect all the breakers of zone 4 to open up to isolate that fault. So that means it will be the same B24, but now it will be together with B21 and B23, and that is how the zones of protection were to work. So you can move this fault into any of these areas. If you had to move the fault to where zone 8 would be, then it would be your B23 and your B32 that would be opening up to isolate that fault. So what type of question can you get asked on the zones of protection? They can give you the system without putting in the zones in it, okay? And then they can say, please show us the zones of protection. So that could be the first thing that they do, and you would have to circle up, circle up, circle up. And how do you do your circling up? Your circling up, always you need to have a equipment accompanied by a circuit breaker. So where before in your previous slide you could see that your generator was followed by a circuit breaker, in this instance your generator goes straight into a transformer, then only you have a circuit breaker. It therefore means that you cannot assume that your generator alone can be a zone. There must be a circuit breaker involved in it. So you make sure that each of your equipment has got a circuit breaker that is covering it up. And usually your lines and your bus bars on either side, there should be circuit breakers that look after it. And that's how you would be able to circle or identify what your zones are like. Then the second part of the questions, once you've identified all of your zones, they can then put in faults at different parts of this network and ask you which circuit breakers will be able to isolate that particular fault. And you have to remember that all the circuit breakers of that particular zone, once you've identified which zone the fault is at, then all your breakers of that zone should be able to isolate that fault should a fault occur on it. So thank you. This was the first lesson of module 4. We will now go into lesson 2.